All right, we're gonna write 11/20 as a decimal right here. And to do that, we're gonna use some long division here. So 11 divided by 20. And the first thing we can see is that 20 won't go into 1, and it will not go into 11 as well. So, you could put a 0 here and say you got 11 remaining, but remember, we want to change this to a decimal anyways. So remember to line up your decimals by the place value in not only in the dividend here, but also in the quotient that we're finding, okay? Because that allows us then to tack a 0 on there, and then we'll continue this until we find that there's nothing remaining, okay? Now, I also look at this number as 110 instead of just 11.0. It's 110. How many times does 20 go into 110? So I'm going to list my multiples of 20, which is a good strategy because it kind of shows us the multiples of 20 without having to think, well, what is it? How many times does 20 go into this number each time, okay? Now 20, the nice thing about 20 is you just take multiples of 2, 4, 6, 8, 10, 12, 14, 16, and 18, and just tack a 0 onto the end. Okay, these are all the multiples of 20. And that's a nice strategy when it works this way, but if not, then we'd have to actually add the numbers. We'll see an example like that today. So I'd say, well, how many times does 20 go into 110? And the closest I can come up here is 100, which is the 5th multiple. So I say 20 goes into 110 5 times, putting that 5 in the 10th place value. 5 times 20, again, looking at that multiplication chart, is 100. So we used up 100 of the 110, which leaves me with the 10 value there, which means I'll also need to tack on another 0 to my 11 and drop it to make that value 100. And then how many times will 20 go into 100? Again, that's the 5th multiple there. So 5 times 20 is 100. So nothing remaining, which is what we want. And that tells us then, since that's completed, that we have also found the decimal value of 11/20. Here's our objective for the day. I can compare and order rational numbers. Take 30 seconds and copy this down, please. All right, just so we understand, when it does say rational numbers right here, it's talking about decimal values, fraction values, but it would also include just regular numbers like 2 or even negatives for that matter. So we need to be able to compare and order those rational numbers. So when comparing numbers, this is just to compare them with these symbols which we've seen before. This one is less than. And then this one over here is greater than. And then the ever-present equal to. Which we don't see too much equal to, but less than or greater than we definitely will see, all right? And in case you forget these, less than kind of looks like an L right there, and then the greater than symbol, if you just tack on a little hook, kind of looks like a G, so that's the greater than symbol, okay? So we're comparing the numbers, and what you'll want to do usually is to write both numbers either as decimals or fractions. Now, if you compare these as decimals, you're going to line up each number by its place value, kind of like as if you were going to add or subtract them. And then you start furthest to the left, the place value furthest to the left, and then move to the right, seeing where the numbers differ. If they're the same, you just keep moving to the right, okay? Now, if they're fractions, all you need is common denominators. We will give you a strategy to force the denominators to be the same. And then after that, you need to compare, that should say numerators. Yeah, so once you get common denominators, whatever they are, all you got to do is compare the numerators, all right? So for the decimals, just kind of show how this works. Like if you had 0.25 and 0.24, you would line them up exactly like this, where you have the ones place value, the tenths, and the hundredths lined up. If there was more, you'd line those up as well. I said 0.24, right? Okay, and then you just move from left to right, and you say, look, in the ones place value, they're the same. So we check that off, we go to the next one. They're also the same, and so we go to the next one, which is the hundredths place value. Now they're different, and so really all you would need to do at that point is compare 5 to 4. Since 5 is greater, we could say that 0.25 is greater than 0.24. Okay, and I know not everyone would need to go that far for values like that, but it may not be so obvious in today's lesson. So that's comparing decimals. Now, if they're different, like let's say that 0.25 was 1/4, you may choose to change that into a decimal and then make the comparison. That's what this is saying. If they're both fractions, remember that the denominators tell us the sizes of the piece. So when these are the same, the denominators, your sizes of pieces are the same. So if it was like 1 and 3, all you'd really need to do is compare 1 to 3. And since 3 is bigger than 1, this would read 1 is less than 3. Okay? And so then you could go back to the fraction and say, well, 1/5 then is automatically less than 3/5, because again, the sizes of the pieces are the same, but there's more of these fifths right here. So again, well, if the denominators are not the same, we'll show you how to force those to be the same though. All right, so comparing these two values, and we just need to enter less than, greater than, or equal to. All right. On the homework, it's going to say that you have to force these to be in like forms or something like terms, something like that. You don't have to, because all we really want on Canvas is less than, greater than, or equal to. Okay. So most students at this point, they would change this 31/20 into a decimal. Most students like to compare decimals. You don't have to. You're welcome not to do that, but it's up to you. So if you're going to do that, then you got to take your 31/20. That's 31 divided by 20, and you got to use long division here, okay? So if you're going to do this, again, it may be helpful to see multiples of 20. So that'd be 20, again, it's 2, 4, 6, 8, 10, 12, 14, 16, 18. Like we saw in the bell work, just tack a 0 onto the end of each of those, okay? So 20, I see that it can go into 31 once. 1 times 20 is, well, 20. And when I subtract this, I get 1 minus 0 is 1, 3 minus 2 is 1. Now 20 won't go into 11, but if I tack a 0 onto my 31 with the decimal, don't forget to line it up in your actual quotient either. But I can take that 0 and drop this as 110. 20 will go into 110. As we can see there, that's the 5th multiple, so that'd be 5 times. 5 times 20 is 100. And when I subtract this, I get, well, I guess we've seen this before, but 20 will go on, it will not go into 10, but if I tack another 0 on here to make that 100, 20 will go into that 100. Again, there's the 100, exactly 5 times, okay? So that gives us nothing remaining, which is what we want to see. But I can tell then that 31/20 is the same as 1.55. So if I'm comparing this with 3.2, again, I would line these up, and I know not everyone needs this, but in the future you may. So I'd say, look, let's look at 3.2 and 1.55. Again, you start with the place value furthest to the left, and I see that 3 and 1, the ones place value, they're already different, meaning the rest of this doesn't really matter. I'm only comparing, well, I guess it'd be 1 to 3, okay? And I know that 1 is less than 3. So when I go back to the original, I can say 1.55 is definitely less than 3.2. So 31/20 is also less than 3.2. And that makes this true, right? Because if you put a greater than symbol here, 1.55 is greater than 3.2, that's not true. Okay? And of course that would be marked incorrect on Canvas. But on Canvas, this is the only part we really want right there. All right, let's compare these two. And again, even at this point, I think a lot of students would make this a decimal right here, okay? Now this decimal will repeat because of the 13, but we'll only need to go to the 3rd decimal place to make these different, okay? But we still need to do the division. Just remember, though, that your 25/13 is negative, so whatever decimal we get from this, it also needs to be shown as a negative. So I'm putting my negative sign out first, and then I will do 25 divided by 13, okay? Now, like I said, we probably don't have our 13 multiplication tables memorized. And so at this point, I'm going to list all the multiples of 13 up to the first 9 multiples of 13, I should say. Okay, so there's 13. Now, you could say 13 times 2, or you could just add 13 here. This is the 2nd multiple of 26, and then add another 13. This will give you each multiple every time. There's 39 plus 13, 2 carry the 1, 52. Plus 13, 65, plus 13, 78, plus 13, 91. Let's see, what is that? The seventh multiple, plus another 13 is 104, plus another 13, this will do it, 117, okay? So I'm gonna highlight all the multiples here, so I know which ones are at the actual multiples. 13, 26, 39, 52, 65, 78, 91, 104, 117. There's my first 9 multiples of 13. And the reason why you have this here is so that I don't have to ask myself every time I look at a number, how many times does 13 go into it? Because I can just refer to my list here on the right. You have to make that list. No, you don't. But I think it's going to save me some time. We'll find out. So let's look at our long division then. Okay, so 13, it will go into 25 once. 1 times 13 is 13, so I can subtract that. 5 minus 3 is 2. 2 minus 1 is 1. So I do need the decimal because I don't want anything remaining. We'll make that 25.0. I'll drop this with the 12 that remained and make that 120. Will 13 go into 120? Yep, looks like it goes all the way up to the 9th multiple, which is 117. So don't forget to put that other decimal. I almost forgot that. But 13 will go into 120 9 times. 9 times 13. Again, I just refer to my table here, 117. When I subtract, I get 3. So let's tack on another 0 there. Drop it to make that 30. All right, how many times is 13 going to 30? Well, it looks like it go up to the second multiple, which is 26. So there's 2. 2 times 13 is 26. And some of you notice, even though I got a remainder of 4, the two numbers match so far. And this is why we will need the third decimal place from this value, and then that should be all we need. So I'm going to tack on another 0. We'll drop it, make this 40. Will 13 go into 40? Yes, it will. Almost exactly, but not quite. But that'd be the third multiple there, okay? 3 times 13 is 39, and then you could continue this on. But since I already have the third decimal place value on the 1.923, and the 1.92 doesn't have that, then I know that I'll have an unmatching value there, okay? So even though this decimal will go on forever, I'm not going to show all of it, and I end up with negative 1.923, okay? And I am comparing this with negative 1.92. So let's compare. So I'm going to list these by their place values. Let's look at 1.92 and compare that with 1.923. And since this 25/13 goes into the thousandths, I will need a 0 to hold that place value for me. So there's a 0 in the 1.92, okay? And then we start furthest to the left, comparing these values. The ones, those are the same. Let's go to the next one. The tenths, the nines are the same. So let's go to the next one. The hundredths, they're the same. So we got to go to the next one. Okay, that's okay. Now we're comparing 0 to 3, right? So the 0 came from the negative 1.92. Again, there's that 0. So we're really comparing 0 with 3 now. But it's actually not comparing 0 to 3 because going back, here, both these numbers are negative. So you got to remember, we can't really compare negative 0 with negative 3. 0 is neither negative or positive. So I'm just going to put 0. But if you had to compare 0 with 3, hopefully we know that 0 is actually greater than negative 3. And you can look at this on a number line, right? You could say, well, there's 0, remember, positives to the right, negatives to the left. So negative 1, negative 2, negative 3 would be right here. So on the number line, negative 3 is further to the left than 0. So therefore, 0 is greater than negative 3, which means going back, that means negative 1.92 is greater than negative 1.923, which also means that negative 1.92 is greater than negative 25/13. Okay? So do be careful if you ever need to compare negatives, which you will on the homework. Remember, the smaller the negative, the more value it has. Or the more negative it is, the less value it has. Either way you want to look at it, okay? And of course, if you wanted to, you could go as far as you want on this division, but it never actually ends on that. That may seem like a lot of work to compare two values. Okay. I don't think it was hard work, but it was a bit of work, sure. How about comparing these two? Well, I got a mixed number and I got an improper fraction. And so what I want to do is change these to the same form, right? So I'm going to make the denominators the same. But before I do that, I need to take this 5 4/5 and change it into a improper fraction. Now that's not going to change the denominator, it'll still be fifths. But I'm going to use some cycle method here to change that into a improper fraction. So that'd be 5 times 5. Whole number times the denominator is 25. And then I would add the numerator 4 to get 29. So I end up with 29 fifths as the improper fraction. We are still comparing this to 35 sixths. Now, these are already fractions, so I will not worry about changing these into decimals. I will compare these with fractions, not only because it's going to be convenient, but because in the future we're going to have to use the skill of forcing denominators to be the same. I right now am going to force the denominators to be the same with a very simple strategy, as long as you know how to do it, okay? If you can multiply, you can do this anytime, and we're going to need the strategy quite a bit in the next unit when we start adding and subtracting the fractions, okay? But I can force the denominators to be the same, and I also will do that without changing the value. That's the important part. I'll change the way it looks without changing the value of the fraction. So I'm going to take this 5 denominator from the left, and I'm going to scale the second fraction up. So that means I'm going to multiply it, both the numerator and denominator, by the first denominator, 5. Okay, and I'll show you what this does. In the denominator, 6 times 5, that's not too bad, 30. But then I'd have to do 35 times 5. I'll do that up here. 5 times 5 is 25, carry the 2. 5 times 3 is 15, but add the 2 is 17. So that ends up being 175 in the numerator. 175 thirtieths. Okay, now it's the same value as the 35 sixths. I just changed the way it looked with 30ths as my denominator. And remember, the idea here is to force the denominators to match. And so what I'm going to do is take this 6 denominator and multiply it by not just the denominator, but the numerator as well of that first fraction. So see how we're just kind of exchanging denominators? What does this do for us? It forces the denominators to be the same, because you just took the 2 denominators and multiplied them by each other. 6 times 5 is 30. See how they match? So I'm comparing the same size pieces. All I got to do now is determine what 6 times 29 is. So let's see if I got enough room for that. 29 times 6. 9 times 6 is 54, carry the 5. 6 times 2 is 12, but add 5 is 17. So this ends up being 174 thirtieths. Okay? Now, be careful, because some students would have stopped right here and they said, well, 29 is much smaller than 35. That's true, but you have to compare these with the same denominators. Why did this come out so close? It's because fifths are bigger than sixths, so you can have less of them and end up having more if you start changing the denominators to be the same. Once the denominators are the same like we see, then all you're really doing is comparing the numerators, 174, and we're comparing that to 175, okay? So right here, I know 175 is bigger, so 174 is less than 175, which means the other fraction, 174 thirtieths, would be less than 175 thirtieths, which means that 29 fifths is less than 35 sixths, which means that 5 4/5 is less than 35 sixths. By the way, this was the same comparison throughout. That's why we know we can just fit this in. We just had scaled the fractions. We changed the way they look without actually changing the value, okay? But again, we had to force the denominators to be the same. Are you going to be forced to use the same denominators on the homework? No. You can change them into fractions, like I said, but that's completely up to you. All right, ordering values. Now, you can always separate positives and negatives. The positives are always bigger than the negatives, that's true. I would usually start with the negatives, that's the second part there. So once you get them separated, order the negatives from least to greatest. Just remember, the bigger the negative, the less value it has. And we've shown that with a number line before, right? So remember, zeros here in the middle, positives to the right, negatives on the left. On a number line, the further to the left you go, the less the value has, okay? So even if I said, look, this is negative 1,000, and then right here, let's say this is positive 10. Even though 10 looks like it's less than 1,000, when it's a negative 1,000, negative 1,000 is less than 10, okay? Or again, if you make it more negative, let's say we're comparing this with negative 50 right here. Well, see how negative 50 is further to the right than negative 1,000? That means it's bigger. Okay, so when you list these from least to greatest, and a number line is a valid way to compare these. But when you order negatives from least to greatest, the bigger the negative, the less value it has. And then 3, order positives from least to greatest. Again, you'll be comparing place values for both. And then once you get the positives ordered from least to greatest, just combine the 2 lists. All right, so here's some decimals. Some of the decimals look the same. And even the fractions we'll find kind of look the same, but they are different. The first thing I'm going to do here is separate my negatives from the positive. I see these 2 negatives here. And let's go and list these. Negative 0.43. Now, is this from least to greatest? Perhaps, but we'll find out, okay? These 2 are already decimal values, so I will compare these as decimals, okay? So, again, they'd be negative, so 0.43. Remember, the bigger the negative, the less value it has. So even when we start comparing these by place values, like the zeros, they're the same, so go to the next place value. Now I'm just comparing 4 to 0, I don't even care about the 3 to 4 anymore, right? I'm comparing 4 to 0, but again, these are negatives, so I'm comparing 4 with negative 0. Negative 4 is actually less than 0, okay? Which means, well, that came from the negative 0.43 here, which is this one. So in order from least to greatest, yeah, we already had that. Negative 0.43 is less than negative 0.04. So that orders all of my negatives from least to greatest right away. Now I need to order the fractions from least to greatest, or the positives. But I'm going to have to change those fractions into decimals. You could change the decimals into fractions. It's completely up to you. But if you do that, you're going to have to force the denominators to be the same. So 43 hundredths. Remember, this as a decimal, by the way, is already in hundredths. So you could just look at 0. You'd have tenths and hundredths. How many hundredths is that? That's 43 of them. Okay, so I changed that into a decimal value. You could use long division if you want, but it may take a little bit more time, okay? And I'm trying to save a little bit of time. Next up, we got the 2/5, which comes out as 2 divided by 5. Well, 5 won't go into 2, so here's my long division, right? So remember, line up your decimals here, make that 20. 5 goes into 20, 4 times exactly. 4 times 5 is 20, nothing remaining. Kind of what we wanted, which means that 2/5 could also be written as 0.4. Okay, so I have all 4 of my positive values as decimals. Let's go ahead and start listing these, and then we can compare them by place value. So I got 0.43. I have 0.043. I have 0.407. And then the 2/5 was 0.4, like this, okay? Now we want to list these from least to greatest, and we'll compare these by place value. So I start with the ones. These ones all match, so I got to go now to the tenths. So I go to the tenths here, and the lowest number here is the 0, which means that 0.043 is the smallest of these 4 values. So I can list that as my smallest, 0.043. Now the 4s all match, 4, 4, and 4. So I've got to, for those other values, I got to go further. And we've already used the 0.043, so I'm going to cross that out. And even right now, what I probably want to do is tack on zeros where there's any empty place values, if I haven't done that already, which I didn't. I'm going to do that now. And I can see by comparing the next place value that the 3 is the biggest, right? You got 0, 0, and 3. Well, since 3 is the biggest, that means I know that the 0.43 is going to be the biggest number of the group, and that came from 43 hundredths. Okay, so that uses up that one. I know it's the biggest, so I've already listed it furthest to the right there, see? Now for those 2 zeros, I'd have to go further to the right on those ones and compare now 7 and 0. And I know that 7 is bigger than 0. Well, where did that come from? Well, it came from 0.407, and the 0 came from 0.400, which came from 2/5. So that would be the next smallest, is 2/5, because it had the 0. And then the next one would be that 0.407. And now this is listed in order from least to greatest. This list. On this one, it wants us to place these values on the number line, and then we'll write them in order from least to greatest. This is a valid way to compare numbers, and then you don't actually have to separate your negatives from positives. You just put them on a number line like this, and then go from there. The numbers furthest to the left are the smallest. The numbers as you go to the right get bigger and bigger. Okay. Now the 1/8 there, we'll need to do some division on that one. So we'll do 1/8 in red. I'll do that over here on the left. So 1/8, that'd be 1 divided by 8. Now 8 won't go into 1, so if I make this a decimal as 10, 8 will go into 10 once. So 1 times 8 is 8. When I subtract that, I get 2 left over. So I'll tack another 0 on to make that 20, right? I gotta make that bigger. 8 will go into 20 2 times. 2 times 8 is 16. When I subtract that, I get 4 remaining, so I'll need to tack another 0 on. Remember, we don't want anything remaining. So when I tack another 0 on, I'll drop it to make that 40. And 8 will go into 40 5 times. 5 times 8 is 40. Now there's nothing remaining. That's when I can stop. So 1/8 is the same as 0.125. And why is this important? It's because on our number line, we can see that the marks go up by 0.1 every time, okay? How do we know that? Because the fifth mark, 1, 2, 3, 4, 5, is 0.5. So I know that this mark here would be 0.1, then 0.2, 0.3, and then 0.4. And then that would continue going to the right. Which means it also works for the same going to the left, except they're negatives, right? So that'd be negative 0.1, negative 0.2, negative 0.3, negative 0.4, and then negative 0.5 is already marked, okay? So each of those marks represents 1/10. But you'll notice that 1/8 is already, like we can go to the 0.1, which is, it's right here. But I'd have to go over a fourth of that. So there's half, there's a fourth. I can mark that up right there and get rid of the half mark right there. Make this nice and pretty. Okay, so I will mark this, but I won't mark it as 0.125. I do want the fraction value that we found, which was 1/8. You'll keep this in mind when you put these values into Canvas. It wants the original value that was written, not changing it into decimals or decimals to fractions. Just write the original value. So there's 1/8. The next value I see is negative 0.41. Okay. So again, this is a negative to start out with. I'd go to the negative 0.4, which is here, and I just go one part to the left of negative 0.4, which is about as close to negative 0.4 as I can go right here. Okay. So that ends up being the value that we already found, negative 0.41. There's that purple point. It's kind of small, but I hope that's visible. Then we go to the next value, which is 4/7. Well, that's a fraction, so I'm going to have to use long division to change this into a decimal. 4/7. Okay, well, 7 won't go into 4, but it will go into 40. Make sure to line up your decimals. 40, 5 times. 5 times 7 is 35. When I subtract, I get 5 remaining. So I'll tack another 0 and drop it and make that 50. 7 goes into 50 7 times. 7 times 7 is 49. Subtract, you get 1. Now you could keep going, and in fact, this fraction will repeat as a decimal. So I'm going to stop right there. Okay, and the reason that is because graphing, especially on this graph, trying to graph the thousandths on this is just too small. Okay, so I really don't even need the 1, but here we go. 0.571, so here's my 0.5, right? Then I need 0.7 of that, so that'd be, about halfway there. And then again, the 1,000th there is kind of obsolete because it's too small. So that ends up being our fraction value of 4/7 right there. Approximately, of course. So we just graphed 4/7. Very nice. Now we're going to graph negative 0.57. Now be careful because some students say, look, it's pretty much the same decimal, so it goes right on top of this one. No, it does not. It's negative. So it goes over here. Negative 0.5 is right there. So I'd have to go 7 parts to the left, but not quite this far to get to negative 0.6, right? It's definitely less than that. So again, I'll just put that kind of halfway between the halfway mark and clean this up. So what value is that? Well, it's a negative 0.57. There we go. Now, the nice thing about the graph is it shows us the order from least to greatest as long as we've written those out. So that is what I will do now. A little bit more space, I guess. Okay, so negative 0.57 was the smallest. And then negative 0.41 was the next smallest. And then we had 1/8. Then we had 4/7. So I'll just split these up with commas, call it good. So this is the order from least to greatest. I just can't emphasize enough how much I don't care which method you use. You just have to be able to order them from least to greatest. That is the important part, okay? So that brings us to the objective. I can compare and order rational numbers. Remember, rational numbers, decimals, fractions, mostly decimals and fractions for this lesson, but also regular numbers as well.